Hello class, welcome to our usual classes, and this is still geography from 1, and we're still on the first topic, and the first topic, as said earlier on, is map work and interpretation. And so today we're going to proceed our topic by looking at converting one form of scale to another. Remember, in the previous lessons, the last part we learned different types or different ways of expressing a scale on a map. So we learned that there are major 3 ways of expressing a scale. So today we're going to see as in how we can change or we can convert one form of a scale to another. That is our major emphasis as for today's lesson. And we're going to proceed by looking at how we can enlarge the map and so on and so forth. For someone to convert one form of a scale to another, you need to understand some basics units. For example, we can say 100,000 centimeters represent 1 kilometer. So this is a basic unit which someone needs to know. So this needs to be mastered by an individual student. The first conversion which we are going to look at is converting a statement scale to a representative fraction. Converting a statement scale to a representative fraction. Now, for example, or if I can call or I can take you back to the previous lesson, I said that the statement as scale usually use weights to express the scale. So here we have an example to say 2 centimeters represent 1 kilometer. 2 centimeters represent 1 kilometer. So this is a statement scale. So our task here is now to convert or to change this statement scale to a representative fraction. So how can we do this? Now, if you can look very clear, there is this statement to say 2 centimeters is equals to 100,000. So it's a basic unit to say that 2 centimeters represent 1 kilometers, which is 100,000 centimeters. So to change this statement scale to a representative scale, you will say 2 centimeters is equal to 100,000 centimeters. Therefore, 1 centimeters will always equals to rice, because 2 centimeters is equal to more, which is 100,000 centimeters. And then if we can say 1 centimeter will always be rice. So when we say it is less, then we'll say 1 over 2. So we'll take this 1 over 2 and multiply by 100,000. So here you do some simple calculations, as you can see. So you will just divide 2 into 100,000. So what do you have? You have 1 over 50,000. This is a representative fraction. So in other words, this can also be represented as in 1 to 50,000. So you have converted, or you have put that statement scale in a representative fraction. Now, let's proceed. Let's now convert the statement scale to a linear scale. For example, you have your statement scale which says a statement scale of 2 centimeters represent 1 kilometer. and you need to change this to a linear scale. So how can we do this? Generally, what is meant here is distance on the map is equal to 2 centimeters, and the distance on the actual ground is 1 kilometer. So we can say that 2 centimeters represent 1 kilometer. 2 centimeters on the map represent 1 kilometer on the actual ground. So we need to put this into a linear scale. So you come out to say that 2 centimeters now, 2 centimeters is equal to 1 kilometer. And here is your linear scale divided into units. So you have on top here as in numbers, then this numbers, the units is kilometer. And down here you have your centimeters. So what is meant here, as we have said, that from the 0 to 2, which is 2 centimeters, and that 2 centimeters is on the map, and on the actual ground, it means 1 kilometer. So from here to here, again you have 2 centimeters, and that is on the map, and while on the ground it is 1 kilometer. So you have presented, this is your linear scale from the statement scale. So you have presented that statement scale to a linear scale. The other one is converting representative fraction to linear scale. Representative fraction to a linear scale. So how can we convert representative fraction to a linear scale? For example, there is this fraction of saying 1 to 100,000 to a linear scale. So you have this representative fraction, that which is 1 to 100,000, or else you can just say that is 1 over 100,000, right? How can you put this into a linear scale? So you will have your linear scale here. So like we was saying that 1 centimeter is equals to 100,000 centimeters. So we want to convert the centimeters now to kilometers. So how can we do that? So this will mean that 100,000, 1 centimeters will always present 100,000 centimeters. Now, here you have seen that there is 0.5. So you might wonder where this 0.5 is coming from. So in simple terms, this represents 1 over 50,000. So 50,000 centimeters are centimeters. So you need to convert the centimeters into kilometer. So we're saying that 1 centimeters or 1 centimeters is equal to 100 centimeters. That is. So if we want to convert this to kilometer, you just divide that 50,000 by 100,000 centimeters, which will give us 0.5 kilometers. So this means that from 0 to 1, that is 2 centimeters, and if you can divide this in half, if you put it into half, then you have 1 centimeter, then that 1 centimeter represents 0.5, while 2 centimeters represent 100 kilometer, or 2 centimeters. So 2 centimeters represent 1 kilometer. Let's proceed by converting a linear to a representative fraction. So you have your linear fraction here, which says that 2 centimeters represent 2 centimeters is equal to 1 kilometer. So here is like 1 centimeter to represent 1 kilometer measures 2 centimeters on the linear scale. So here it's like you have 1 centimeters that represent 1 kilometer, and that is measured as in 2 centimeters. So the 2 centimeters we are talking here is like from here to here, there's 2 centimeters. And in this centimeters, it is also represents 1 kilometer. So this could be converted to 2 centimeters to represent 2 centimeters, represent 1 kilometer. So it means that the 2 centimeters is equals to 1 kilometer. So therefore, 1 centimeter, which represent 50 kilometers, and that is 0.5 kilometers, equals to 1 to 50. And this 0.5, if you can multiply by 100, you find that is 1 to 50, and that is 1 over 50,000. The other one is now converting the representative fraction to a statement scale. So you will have your representative fraction here as 1 over 50,000 centimeters, and you need to convert this to statement scale. So in simple terms, you can just say 1 centimeter represents 0.5 on the actual ground, and that 1 centimeter is on the map, and on the ground is 0.5 kilometer. Right. We have looked at the ways of converting the fractions from one form to another. The next thing which we need to look at is now we have converted these different forms of scale from one form to another. So the next question is, how important are the ways in which scale is used? So we're going to look at the importance of the scale. One of the first importance of the scale, is it helps to maintain dimensional accuracy by preventing distortion when drawing maps. It helps to maintain dimensional accuracy by preventing distortion when drawing maps. The other importance is it helps to calculate distance and areas accurately. So if you would like to find the distance on the map, it means you need to have a map. So the map, or you need to have the map as well as the scale. So actually the scale is the one which is used now to calculate the distance and also to find out the area of a specific ground. The scale also helps or it reduces or save paper and space. So as we have seen that a map is always drawn to a scale. So it's like you can present many of stuff or the huge of the map on the small piece of paper, as long as that map is drawn using a scale. So in that case, you can have maybe a small piece of paper and draw a map. The other importance is that the scale also helps to save time than the actual measurements on the ground. It also helps save time than the actual measurements on the ground. Now, we have looked at the importance of the scale. So let's proceed our lesson by measurement of distance on the ground. So we need to look at the ways of how we can measure the distance on the map. So there are several ways of how we can measure the distance, and some of the ways of how we can measure the distance includes: one, you can use a straight-edged paper. The other one is you can use a pair of a divider. You can also use a ruler. You can also use a string. You can also use a pair of compass. Now, we have mentioned these ways of how we can measure distance on a map. Let us see how we can measure distance on a map using a straight-edged paper or a straight-edged piece of paper. Right. So there are several steps which you can follow when you want to measure the distance on a map using a straight-edged piece of paper. So the first step is that you need to draw a line joining 2 points. That's, for example, if you are asked maybe to calculate the distance maybe from point A to point B, it means you need to connect these two places by drawing a straight line, and that straight line will also come from A to B. So it's like you draw a straight line, and that straight line is like you have joined the place A and the B. So the second step is then you get a piece of paper of a suitable length which has a straight edge. So you get it can be any kind of a paper, actually a piece of paper. So that piece of paper should have a good length with a straight edge. So usually the edge should be that smooth. So after there, you press the straight edge edge of the piece of paper to the next line being measured, that is A and B. So you take that piece of paper and press it on the line which you draw, that is which connects the two places A and B. So you press it on that line, that piece of paper. Then after pressing that, you mark off the straight edged piece of paper against those points of the feature that appears to be straight. Now, you only mark on the piece of paper, that is with your pencil, or maybe you can use a pen, and that is when or that is where the features are straight. And then after measuring that, you take again that edged piece of paper and take the marked length of piece of paper to the scale. So you usually have that scale which was provided on the map, and then you place it as in you have seen in this diagram. So you have seen there's point A and there's point B here. So this is your edged piece of paper, as you can see, and then you mark at the areas where the distance of these two places has reached. So you mark here and you mark here, and after marking here, then you take this piece of paper to scale and place on the scale and find the distance. And after finding the distance, you convert that distance to the recommendable scale. Number two, or the other way of measuring the distance, we can also measure distance of winding distance on a map. So you can, in this way, we are trying to express something else which that is not always in straight. Some features that may be winding, and winding, we're talking of, they have some bendings. In this case, we can give an example maybe of a road. Some roads may not always be straight. So sometimes when they also ask to measure the distance of a winding feature on the map. And now we're going to see as in how we can measure the distance of a winding feature on the map. So in this case also, we have several steps which you need to follow so that you can measure the distance of the winding feature. So the first step is you get a string. So in this case, you need to have a string. It can be maybe a thread. Yeah. So the first step is you take that string, you lay along the root to be measured. You lay along the root to be measured. So you can also be measure the distance of this winding rod from this point to that other point. So you take this string and lay along this the winding feature, and then you follow the curves. Follow the curves carefully. So the second step is that you mark the string with a pen where it ends on the side of measured length. So when you reach at the ends where you've been asked to stop, you mark it with maybe the pen or the the pencil. Then after marking, you then take the measured length against the scale to find out the distance of the measured area and actual ground. So you can see on the diagram. So you take your marked string and place it here on the scale, which is actually on the map there. And then after that, you place this scale or the unit which has been found here, and place it as on the actual ground. You, in terms of expressing this, you just follow the procedures of how we were converting different types of scales to another. So that is how you can measure distance on the map. Right. Now we're done measuring the distance on the map. So let us look at map enlargement. Map enlargement. Map enlargement, in other ways, on simple terms, can say that we are trying now to enlarge the map, maybe giving it a small map, but then, which is always drawn to scale, but then we can enlarge that map. So this is the next thing which we are going to learn in this lesson. Now, in terms of map enlargement, we are saying that this is much easier if the map is drawn to scale on topographic map. So we always have a topographic map which is drawn to scale. Now, when we're enlarging maps, we should always have in mind that we need to maintain the same number of boxes as in the original map. So you have to make sure that the number of boxes you are, or the number of boxes which are in the original map should be maintained. However, there may be slightly larger than its original boxes, depending on how big your map would be. So in terms of map management here, so we're saying that you have a number of boxes, but then these number of boxes, if when you are enlarging, might be bigger than the original size. But what we're maintaining here is the number of boxes. So you have the exact number of boxes. But in terms of the size of boxes, now when you have enlarged that, it means that those boxes in the enlarged will be bigger than the original boxes. And that depends on how you want your map to be like when you are enlarging. We can usually use a graph paper for this purpose, because the graph paper is always presented to a scale. So because of that, it becomes easier for students to enlarge a map because the scale is already provided. When enlarging the map, its scale may change depending on how big your map has grown. So it always depends on how you want your map to be like. So here there is an example. If you can see, the first map here is the small one, and then there is the second one which has been enlarged. Now, if you can look at the small one, this has also been drawn to scale. We're saying that the first one is 1 to 100,000, and the second one is drawn to 1 to 50,000. So this has been enlarged. But still more, if you want to your map to be bigger and bigger. This can also depend on maybe the surface which you have or the piece of paper which you have. So those are some of the factors maybe considered when you are enlarging the map. But all in all, what we are saying is that the boxes now, they may look bigger than the original. As we have seen the map of Malawi. You can count the boxes here, they are the same as in these boxes of the enlarged map. But in terms of the size now, they are different. These maps from the first map are smaller, while the other ones are much bigger than the first or the original boxes. Right. Now, usually when we want to find the scale of a rated map, the following is the procedure. So we always have 1/5,000, which is always times to 1/2, and that will give you 1 to 50, or 1 over 50,000, or 1 to 50,000. Right, we are done with map enlargement. Now let's continue our lesson by looking by calculating an area of a map. How can we calculate an area of a map? So on a topographic map, each box normally represents 1 kilometer. So it means that when you have that topographic map, the box itself always represents 1 kilometer square. So therefore, it means the map, if it comprises or it occupies 10 boxes, then it means its area will be calculated as follows. So 10 kilometers, 10, sorry, I should take it again, should be 10 kilometers times 1 kilometers, which equals to 10 kilometers square. So this was saying that we have to multiply the number of boxes multiplied by 1 kilometer, because we are saying that 1 kilometer square represents 1 box. But sometimes you might not always have regular shapes on the map, so there may be some irregular shapes. So now the other thing which you need also to know is that you can also still calculate the area of an irregular shape on the map. So the question is, how can we do this? So for example, you can do or you can calculate the area of an irregular shape by still counting the number of full boxes. For example, you can say we have 10, and then also count the number of half boxes. So in this case, we can say the number of half boxes are 4, and then to find the total area of that map, you can say area of the map is equal to 10 plus 4 divided by 2. That is the total number of halves that is divided by 2 plus the number of full boxes. So for example, you have this here, you have this map in yellow. So that maybe ask your question to say calculate the area of the map. Now the first step is now you need to count the number of full boxes. So let's see, how many full boxes do we have here? So we can count it 1, 2, 3, 4, 5, 6, 7, 8. You have 8 full boxes. Then they put it on the side. Say full box of 8. Then what about half boxes? So you can say maybe 1, 2, 3, 4, 5, 6. So you have 6 full half boxes. Then these half boxes should be divided by 2, and then to find the total area of this map, then you add the full boxes plus the half boxes divided by 2, and then remember the unit is kilometer square. Then you say after finding the total, then include the kilometer square, which is the unit. So that is, so here is what I was explaining. So you just say number of full boxes, you record the number of half boxes, then record, then area of the map will be full boxes plus half boxes divided by 2, and then that will be your area of a map. Now so in our next lesson, we're going to look at the types of map symbols. So if you have time, you can still go to the library and look into the types of map symbols, so that when you come the next lesson, you should have something else in our mind. So for today, let's stop there. Goodbye.